Okay guys, I just wanted to take a brief look at the advent of code. I wanted to introduce you to the advent of code. I imagine this video is going to take about 7 minutes. We're going to walk through the first challenge, the structure of it, and an implementation in Rust, which is a language that you will be new to. If you want to see me implement it in Java, which is the language that is required for the robotics team, and potentially in the future Python, then please come to Java Club, which will be on Wednesday lunchtime. Let me just get a date for you. Wednesday lunchtime will be Wednesday the 4th of December, and it will take place in IT2. Okay, let's get started. So it's like any other advent calendar. We have the days and we have a new challenge every day. Okay, there's a brief bit of setting the scene which you can read yourself. Let's take a look at the actual problem. Each day there are 2 problems. So they've ended up with 2 lists, and the lists aren't very similar. The lists are off by a small amount. Pair up the smallest number in the left list with the smallest number in the right list, second smallest, okay, and so on. So clearly they want us to get these lists in size order. Now we're actually working with quite a large data set here, which is what requires us to implement this in code. What does it want us to do? Within each pair, figure out how far apart each pair of numbers is and add up all the distances. Here we have an example which you can read through at home. Okay, let's take a look at how we've implemented this in code in Rust. Cool, so we're in the IDE. I've written some utility functions. I wanted to work directly from that text file that they provided. You could have also done it by pasting it into Excel and copying out the columns, but we both got the same result in the end. So I'm basically just opening a file, creating these new vectors, which are just arrays of 64-bit integers, which represent each column. Let defines the variable, mute means the variable can change, short for mutable. So we're just iterating through each line in the file and pushing the first value to the first column and the second value to the second column, and then we're returning those out of the function as a tuple, which you also have in Python. I also wrote bubble sort to order them in size just because it's quick to implement. A note to those of you doing GCSE computer science, you will need to be able to implement bubble sort, merge sort, and insertion sort in Python, which is the language of the exam. So if you don't know how to do that, then this can serve as a revision tool for you. Okay, let's take a look at the actual main function. We're defining the file path up here. We're using R to ensure that these slashes don't represent Unicode escape characters. We're defining some more vectors for the columns. We're defining the rolling sum that we want. We're then calling this function in a way that handles errors, and we're going to stop running if we encounter an error when we get to the file. We're getting the data out of the function by taking an R tuple of results and just assigning that to these variables up here. Hope I'm making sense so far. Then we make a brief check here. We just check that the arrays are on the same length, which they are in our input data set. Then we run our bubble sort function on each column, which we implemented up here. Then we iterate through the length of the column. We could have chosen column 2 because they're the same length. We let the left be a 64-bit integer, which is the element of the array in column 1, and the same for the right. Now we need to compute the difference between those 2 numbers. So we hit a slight problem here because what we want to do is if left is bigger, we want to do left minus right, and if right is bigger, we want to do right minus left. Now we can just implement that with if statements, but a much quicker way is to take the absolute value, which you will learn about in maths if you take maths A level. What it means is basically just to remove the negative sign. Okay, right. Then we just print it out to the console so that we can do it. Let's run the code here. Took a little while, didn't it? That's because we implemented bubble sort and not a more efficient sorting algorithm. Okay, and we got the correct answer for part 1. By the way, those answers will be different to yours because the data sets are different. Okay, Right, now let's actually read through the description of the second one. Let me just get back to the browser. Cool, my answer was correct. Right, part 2. Your analysis confirmed the two lists were very different, blah blah blah, more backstory. You'll need to figure out exactly how different each number is. So what they want us to do is compute a similarity score. They tell us how to do that. How do we do that? We add up each number in the left list after multiplying it with the number of times that it appears in the right. So I found that quite confusing, but what it basically means is that we have the 3 here. We see it occurs twice. So we do 3 times 2. What does it occur twice? No, look. It occurs 3 times. This is why we write code and don't do it in our head. And we multiply them to get 9. Do the same with 4. We keep going. And then we just sum all of those values together. And that's our similarity score. So this is quite a long process to write out just because humans struggle to understand something like this. But we can actually implement it in a very beautiful and short way in code. Now, those of you who aren't familiar with Rust, this is going to look quite alien to you, but I assure you that these are concepts that you will find in other languages once you get to a sufficient level. So what we're doing here is essentially we're just doing it all in one variable. We're calling it similarity score. We're saying it's going to be a 64-bit integer. We're then iterating through all of column 1, which, remember, column 1 was our left-hand column. So this iter, as it just creates an iterator, which just provides some nice functions. So we can do, iterator.next, but that's all handled in this map function. So what the map function does, it's a bit like we're doing a for loop. We're just iterating through it, and we're running some code at each point in the array. So we do let count, and we're going through column 2, and we're iterating through it, but we're applying this filter. So what we're saying is that we want column 2, but we only want column 2 where n is equal to I. And in this case, n here, please ignore the ampersands and the asterisks. They're only useful in Rust, and you probably won't need to know about them. So we're just saying we want n is equal to I, where what was I? I was our value in column 1, and n was our value in column 2. So now that this code here has given us that list, and then we're calling .count on that just to count up all the values. Cool. Now we have this count, so now we know how many. What we need to do is we need to do some specific stuff to Rust here, because we're working with the usize type and the i64 type. This might get a little bit complex, but you should be okay. I'll explain it. So what we're doing is we're doing the checked mul function on I. And this is just checked integer multiplication, but we're being very careful to avoid the overflow error. So those of you who do GCSE computer science will know that if you're adding up two numbers in binary, one problem that you can have is an overflow error. Now here we're actually representing our numbers as 64-bit binary integers. So we have to be careful to avoid our overflow error. So what we're saying here with the unwrap or function is we're saying that we want the successful value, but if it failed, we're going to say that actually just assume it was 0. So we're saying that in the case of the overflow error, it was 0. So now we've got another list of column 1, but we've just changed the value to be this number of times that it occurred. So let's take a look. Let's see if we're on track. Let's go back to the website. Yeah, look, you can see here that we've got this list of values. What does it ask us to do next? This plus this plus this plus this, 31. So how do we do that? Well, we can literally just call .sum, and there we go. That's part 2. Okay, how are we doing for time? Yep, it took a bit longer than planned. Sorry. Again, please come to Java Club. Because as you can see, these problems are pretty difficult, just to help you. Alright, see you then.